G'day everybody and welcome back. I had a bit of a win on Facebook Marketplace and picked up this Vertex dividing head. It is, I believe it's a BSO. It come with that backplate is all it come with. So I'm going to have to build a new backplate to adapt this 130mm chuck to it. I could modify this backplate to suit, but by the time I turn this original register off and turn the new one on for this chuck, there's going to be bugger all meat left here, or it'll be a lot thinner. So I'd rather just put that away and build a new one. That's 1 1/8" 12 TPI thread. I did turn one up yesterday, so when I do cut the thread in the new one, I've got a like a tester, if you want to call it that, which just does screws on very nicely. So that'll do that part. I got a piece of 25mm plate to build it out of, so we'll go over to the lathe and see if I can have a win. Okay, so here's a bit of plate I got. I've cut it out rough, just in the bandsaw square. I'm going to try and mount it in here. I'm going to get a dead center now and put in between the two with an indicator and just indicate that in. It's probably close enough where it is, but I'll just get it as close as I can. In 0.02, close enough for what I want to do here. Okay, I want to face this off to start with, just try and clean it all up. Quite a crap finish, one would say, but that's just part of it. I'm thinking what I'll do the internal thread and the register, and then I'll start peeling off all this backside here, and then I think I'll take it out, I'll put the 3-jaw in, and then I'll make up another male thread with the register, so I can screw this one onto it. Then I know it's concentric to the, well, everything's concentric to the register. Then I can turn the OD and then turn the register for the chuck, and I know everything's all in line. I think that's what my plan is. Hope that was clear, because not real clear in my head. But just out of curiosity, I want to run a TNGG insert down that just to see what sort of finish it's going to give. I won't film it all, it's just for curiosity more than anything, so when I go to do the finished pass I know what I'm sort of dealing with. Look, it's a bit ordinary that, to be honest. It's a bit of a play with speeds and feeds, but at least I know what I'm up for now. I'll start putting this thread and register in the guts of it. To do this 1/8" 12 thread, it's got to come out to 26.3 mil to cut the thread in it, and the register that goes on all the is 1¼ inch. So I'll get this drilled out and then we'll bore it from there. Slip in with a 23.5 mil drill now. I used this the other day and I did give it a bit of a lick on the grinder, but see how it goes. Just because I ground it doesn't mean it's any good. That didn't cut too bad, eh? Yeah, I'll get a measurement on that and take it out to 26.3. We're around 23.94. .38. Good enough. Okay, now I've got to put that register in, the 1¼ inch register, which is 8mm deep. So 8mm in, out to 1¼ inch, and that has to be really spot on. .75 holes chase, and I got, where's the glare? 31.752. I can deal with that. I'm going to get set up with the threading tool and do that internal thread. Okay, we are set up to do this thread. I'm going to leave the lead screw engaged, but I will start it on a number, so if I do have to disengage it, I know where I am. That's going to be it. Got a little bit of play. That register's going to hold it up anyway. It's going all the way through. that's it. So what I want to do now is we'll remove this material down to that diameter, which is approximately 50 mil. Okay, that's going to do this side of it. So I had to stop what I was doing and repair this, or make a new shaft. So I was making a backplate for the dividing head, and this fella smashed this shaft in half. Done a number on it. So I built him a new one. And it gets pressed into this hub, welded on this side. And there's a sprocket here with a bearing in it. Runs up on here. Yeah, so there's two bearing surfaces here, a seal surface, that's another bearing surface, that's where it gets pressed into this hub. So that was a fun little one. So hopefully I can get on to doing my stuff now. Won't that be good? Rightio, so back onto this backplate mission. What I've done here, I've cut a new thread, the same as what's on the dividing head with the register. I haven't moved it in the chuck, so everything is concentric to the lathe. Now my plan is to put this on. So now I can turn this side, clean it all up, put the register in for the chuck, and I know everything is concentric to that register and thread. I think that's the way to do it. Okay, so what I've done here, I've marked that at 140 mil diameter. I'll take that out and just knock these corners off with the grinder, just cut them off, just save a heap of work on the lathe. Okay, so I did start off with the grinder and I got two flats off, and then I put in the bandsaw. It was a bit easier. Now I can just make it to 130 mil diameter. So I've got 132 on the DRO, 131.99. I might just take it to 131. Might swap it over to a TNGG insert to do that. But I can do that after. I want to get this face done while this tool's up. Okay, we're going to have a crack at doing this register now. So 100 mil register, 100 mil diameter, and it's going to be just over 3.5 mil deep, if you want to call it that.
That's not real cool, is it?
Doing it like that makes it easier to put it in the bin instead of picking it up all over the floor. Nice little bird's nests. That is 3mm deep. Get rid of my little nest again. How pretty. Oh, nice. Was fortunate enough to pick up a set of these 300mm dial type Mitsutoyos. As you know, I've got the digital set as well. A mate of mine had these and he wanted to sell them, so I was more than happy to buy them. So it's telling me 110 neat, 111 neat. Well, that was almost a mistake. I went to 110 instead of 100. Off camera I'll just slip this down to 100 or close to 100 and bring this back. Okay, we'll see where it should be at 101 or as close as. Yeah, 101. That is 100.1. Oh man, that is real. Oh, that is close, as in a little bit of emery on that, and I reckon it'll go. I want it to be nice and tight. I'm just going to face that off again. There's a bit of a ridge in it. Okay, I'm happy with the way that fits. Happy with that surface. I've got to break this edge and somehow break this little edge where the thread is inside here. Okay, I just went in there and broke that, as you've seen. I think you've seen it. It's left a bit of a wild burr, so I'm just going to face this off lightly. Yeah, that's good enough. There's our backplate. Pretty happy with that. So I'm just going to work out whether I'm just going to transfer punch the holes for the mounting bolts, or whether I go the trouble and indicate, settle up in the mill, and then use the hole pattern circle. Yeah, hole pattern circle, and just do it all that way. I'm not too sure. I thought I'd better do this properly instead of just transfer punching it. So I've come up with this idea. Okay, we've found centre. I've just got to do the DRO, 115mm PCD, and punch the 3 holes in. They've got to be tapped M8, I think. Okay, I've gone through, double checked myself on the 3 holes patterns, on the 3 holes with the texture in the chuck. All looks good, so just gonna go through and just do each hole individually. It's a bit more swapping around, but it's only 3 holes. That's them 3 holes done. Okay, I just went over to the lathe and just faced that back off again. Them chamfers are miles too big because I screwed the first one up. I used one of them, a normal countersink, and it sort of, yeah, I didn't have it mounted down and it took out a chunk, looked crap. So I used one of these zero flute ones. Just went a bit deeper and then faced it off to try and make it look a bit better. Anyway, I'm going to mount it up to the dividing head now and see how it all looks. It's locked up. I'm pretty happy with that. It looks alright. The bolts are the perfect length too. They only just below the surface in here, which is good. Anyway, that makes another complete tool I can use. And the other thing I would like to make at some stage is a set of keys for it to fit the mill. That'll be another day. Won't be today. But I've never ever used a dividing head, so I don't know what other plates there is that come with these. I've got to try and purchase a tailstock. Either that or find a really good set of plans to build a tailstock. I don't know what to do there. Whether I just try and build one or buy one. Yeah, and the other thing is, yeah, like I say, I don't know what other plates are meant to come with these dividing heads. I haven't really searched it up on the internet either. I've got this dividing head bolted down to the table. That's a half thou indicator. It's set on 0. I'm just going to do a full lap and see the run out. Keeping in mind that's a half thou indicator. I don't expect this to be perfect. So that's one full rev. We're back to naught. I believe I got, let's check it again so I wasn't watching. So that's about 3/4 of a thou on that outer, right on the outer ring, which, considering I built it, that's not too bad. I can sort of live with that. Right, yeah, I've just bolted the chuck back on, and I haven't got the lights or nothing on over here to try and stop the glare, so it's, well, the light's a bit crap. So we're on 0, I'll just do a full rev. Half thou. So I'm going to get about the same. So that's 1 full revolution. So we've got just over half a thou of run out on the chuck. I don't think that's too bad. Well, there we go. It's another tool finished. I hope he's enjoyed that. Sort of got a bit mucked up when I had to build that other shaft. Yeah, I sort of lost my train of thought when I was filming, and when you get interrupted. Anyway, I hope he's enjoyed that. Now I've got another tool I can use. It was a good marketplace find. Like I say, I just got to find the tailstock now, or make one. If someone's got a good set of plans to make a really good tailstock, then yeah, if you just want to share the plans, then please do so. Anyway, thanks for watching, guys, and see you on the next one. Hooroo!